Recording in progress.
The second order differential equations are going to look like this. Okay, so this is, remember, this is the second differential. Plus there will be something t dy over dx, and plus then there can be anything like t and q are kind of constant. Let me put all this on q, and that will be just a y. So this is how the second order differential equation look like. When we talk about the differential equation, let's say we write the differential equation as y equal y plus dy over dx, and let's say that's equal something here. Let's say I put 5x. This thing is called the differential derivative, and because there's an equal sign, hence it's an equation. Now the order, when we talk about the order of the differential equation, it's the highest derivative. So if the highest derivative is 2, the order is going to be 2, the second. Here the order is 2. Yep, so we see that one. Now if in this one, the order is 1 because dy over dx, the power of that differential is just 1. Okay. Now, if we have a look, let's do one example. Oh, sorry, before I do, if that's a cube here and that's a cube here, the order of this equation is going to be 3. This is not a 9, it's a cube. Yeah. Okay. Now let's have a look at how do we solve the second order differential equations. Okay, now let's say, I'm just going to clear that one. Now let's say I got a question, d square, just find that one. D square y over dx square plus dy over dx equal, or let's say minus, let's say 6y equal 0. Let's say we do that one. To start with that, you need to actually make some assumption. Okay. Because this is second order differential, so we need to make an assumption. We say let y equal e to the power rx. So we make an assumption. Now I need to find the dy. I need to differentiate it. Then you differentiate. That becomes a dy over dx. This thing, differential of that one is exactly same, e to the rx, but we said the r will come out, so the r will be here. Yeah, that's how we differentiate that. Now let's differentiate it again. Now differentiate again. Now I'm differentiating with respect to x. That becomes the r squared e to the rx. Yeah, because another r will come out. So we got that bit. Now, I'm going to call this one as equation 1. And I will call this as equation 2. And I will call this as equation 3. Now, I will put the equation 1 and 2, no, sorry, 2 and 3 in the equation 1. So in this equation, I put that one. So instead of that bit, I write r square e to the power r x, plus instead of that one, I write r e to the power r x minus 6. But why was e to the power rx equal 0? Let me just move the camera a little up. So I got that equation. If I take e to the rx common, I'm left with r square, because that's out, plus the r minus 6 equal 0. I got that one. Now e to the rx, I move on the other side. E to the rx, I can move on the other side, and that becomes 0 divided by e to the rx. So I'm only left with r squared plus r minus 6 equals 0. Because that thing divided on the other side becomes a 0. 0 divided by anything is just a 0. So I got that. It's going to be like this, which is just a 0. So I don't do that. Now we got this thing. Now this is quadratic equation. If I solve the quadratic equation by factorization or by the quadratic formula, I can have two factors. Think of two numbers. When you multiply, the answer is minus 6, but when you add, the answer is just 1r. So it is minus 3, no, actually plus 3 minus 2. You can do that straight in your calculator as well. So what does that mean? I have to put this thing equals 0, r plus 3 equals 0, which will give me r equal minus 3, or I can put r minus 2 equals 0. I can put that equals 0, that equals 0, which will give me r equals to 2. So I have two values of r. What's that thing? Have a look. I'm going to call this one as equation A. I'm going to call this one not A. Let's call it 1, 2, 3. I'm going to call it equation 4. Let's say. Now I'm going to put this value of the r in equation 4. Now put these two in equation 4. So I got two answers. Y equals to e to the minus 3x, if I put instead of r minus 3, or I got y equals to e to the positive 2x. So these are the two solutions I got. Now this is not the final answer. To do that one, we need to get some more general equation. So let me just write this one down. Y equals to minus 3x, y equals to 2x. So we got this bit. Let me drop it. Let me just pause the. Thank you. So what we have done so far, that was not the final answer. To get the final answer, we need this thing. Y equals to, so this is the notation. You need to memorize this notation. A plus the B. Now we have two answers already for the y. It's y equals to the ay plus the by. We have already two answers for the y, 2x, and here we got the minus 3x, yeah? So that's what we got. Now what I need to do is, I need to differentiate that bit as well. So let's differentiate it. When I differentiate, this side is going to become a dy over a dx. This side, now a and the b, the one, the blue, they are constant. So that side will become a e to the 2x, and the 2 will appear here. And that will become b e to the minus 3x, and a 3 will appear here. But because it's minus 3, so that will change it to minus. So this is from positive, it becomes a minus. Now let's differentiate again. Let's differentiate again. If we differentiate again, we will have d square y over a dx square. And this one will become, another 2 comes out, 4a e to the 2x. Now this minus is already there. The other minus 3 will come out, so that becomes a positive 3. Yeah, positive 3, and then 3, that's 9. 9b e to the minus 3x. So I got that one. What was our original equation? This is our original equation. So I'm going to put this thing and this thing back in this one. So this will go all the way here in this one, and this will go all the way here in this one. And then I will get another equation. And the y is, oh yeah, and this one as well. This one goes here. So that is going to be quite long now. So you need to save right tiny in your equations. It's not going to fit. So instead of d square y over dx squared, I will put this thing. So I'm just going to do that in brackets. So that becomes a 4a e to the 2x plus 9b e to the minus 3x. That's that one. Plus I need that value. This value is here. So I got 2a e to the 2x minus 3b e to the minus 3x, and now minus 6. Minus 6 is already there, and instead of y, I need to put that one. A to the e 2x plus b to the e minus 3x equal 0. So I got that bit. Now I need to open up the bracket and I need to solve the brackets. So we open up all the brackets and we actually solve the brackets and simplify them. We see how much we can simplify. So that will become 4a e to the 2x plus 9b e to the minus 3x plus 2a. Yeah, so I'm going to write it here, much easier. Plus 2a e to the 2x, and it's a plus, I put plus here, minus 3b e to the minus 3x. Okay, now there's a minus. Minus 6 times that is minus 6. Minus 6 a e to the 2x. Minus 6 times that thing will come minus 6b e to the minus 3x. Yeah, and that's everything is equal 0. So let's check if that's equal 0 or not. Have a look here. This is 4a e to the 2x plus 2. That's 6a minus 6, that's 0. So that becomes a 0. This is 9, and that's another minus 3 minus 6, another minus 9, so 0. So you can kind of check the answer like this. Is just to check if we got the right answer. Yeah? Any questions so far? Let me just pause this. Okay. Now we follow exactly the same process. So now I'm going to say r is dy over dx. Yeah, I will say r is dy over dx. So I will get so I can get 9r squared minus 6r. Okay, now I got that one. So if I integrate this thing, on this side, because I got r dx or dy. So that will give me y as 1. So 1 equals to 0. Yeah. So I got that one straight away. Now I need to solve this one. How do I solve this bit? 9r squared minus 6r minus 1. I can use a quadratic formula. So I need to find the r. So here first a is 9, b is minus 6, and c is minus 1. I'm using quadratic formula, which is something like this. R equals, because I'm finding the r, minus b plus minus b squared minus 4ac over 2a. We put the values of the a, b, and c, because the quadratic equations look like this. Ax squared plus a bx plus a c equal to 0. So anything with the square thing is a a, anything with that one is a b. We take the sign as well, minus 6, b is minus 6, c is minus 1. We put that in this formula. When we put that in this formula, minus b, so that is minus 6 plus minus b squared. So minus 6 squared minus 4 times the a, which is the 9, times the c, which is minus 1. Make sure you put minus 6 in the bracket and then square it. Otherwise, you will get minus 36, which is wrong. Yeah, that should be 36. Times 2 times a, which is 9. You put that one, you will have two answers. Now, your answers are going to be 6 when you put that one, plus minus. When you solve this one, this is going to be 6 root 2, like that. Divided by 9 times 2 is 18. Yeah. You can further simplify. When you put that in calculator, you simplify. Try to get the exact value. Do not do that in decimal. Yeah. When you do that one, you can divide everything by 6. 6, 6, 6. So that will become 1 plus minus root 2 over 3. So the r has two values. One value is 1 plus root 2 over 3. And the other value is 1 minus root 2 over 3. So these are two values. Now, you know the equation. Answer look like this. Y equals to A. That was the equation answer. A, e to the power of the r plus b, e to the power of r. That's how the answer for this equation look like. How we know that one? This is the notation for that one. Instead of r, just put the value. So now you're going to do y equals to A. E is there. Instead of r, I will put 1 plus root 2, doesn't matter which order, over 3. So that's the value of the r, plus b, e to the power 1 minus root 2 over 3. That's it. So these are your answers. Now, obviously, I missed one thing. It's e to the power of rx, yeah? And that will be x there. So you need to write the x here and x here as in power. So this is your solution. So these x on the top appears. Yep, that, and that. Okay, let me just pause that one.